Hello, people.
Hi,
Welcome
it's
to
afternoon.
Calculus.
It's afternoon. We know you've missed these videos. Ooh, and here we go. That's a bad sign. I think that means, oh, it was turning colors.
It still is. I don't know.
Okay, well, whatever.
You can't tell.
We are going to talk about the law of cosines today. Law of cosines is a special couple of formulas that lets you find lengths of sides or sizes of angles when you do not have a right triangle. Now, when you look at these formulas, this looks like, oh my gosh, 6 formulas. But honestly, you really only have to know one. And then if we took that formula and we solved it for the cosine of A, let's just do that. I'm going to make this term here positive, so I'm going to move this over there, which is going to make this 2bc times the cosine of A. And if I move that way, then we're going to move the A squared this way, which gives us b squared plus c squared minus a squared. And if we were going to solve this, how would we solve that? We would divide this side by 2bc. So I have b squared plus c squared minus a squared all over 2 times b times c. So this is the form that we use right here when we are looking for an angle. And then, of course, once you're looking for your angle, you know that you would do the angle whose cosine is all of that stuff that's up there, okay?
Now, your question might be, well, how do I know which one's A, B, or C, or big A? Well, the angle is opposite the side that its labels match with, okay? So if we're looking for the angle A, we're going to use the opposite side is A, and it doesn't really matter which one's B and which one's C. It's the ones that aren't next to it.
Notice that side B and side C make up the angle that we know. So we can use law of cosines when we have side angle side. So notice the two sides and the included angle, or when we know something about all 3 sides. Now, there's something we want to know about, how did we come up with this triangle? I mean, how did this formula happen? Well, there is a way that this happened. Oops, I didn't erase that, so I'll just do that, and I'll just do that. Okay, the reason this works is if we take a perpendicular from, let's just say, side C, and let's put our A at the origin, and let's put C at some point xy. Now, notice that because we have dropped a perpendicular, that this height here is y, because that's your vertical length, and this length here is x. So that gives this point the point x, the coordinates x, y. Well, if we have a right triangle, notice that what we have is we have an adjacent side, and so the cosine of angle A would be adjacent x over hypotenuse B, right? And let's look at angle B, and we know that, excuse me, not what I wanted to do there, lied about that. And we know right here that the sine of angle A is the side opposite over the hypotenuse, okay? Now, let's look at what we can do with this right here. This right here becomes x equals b cosine A, right? And this right here becomes y equals b sine A. Now, it's kind of hard to see what's going to happen with these, but we are going to do some craziness with this. Got to make things smaller. Okay, we're going to use that information in the most important thing we know about, which is the distance formula. Okay, so if we talk about our point here, we have B at some point C, that length right there is C, and the y-coordinate is 0. And you can see that our coordinates at point C are x, y, and our coordinates at A are 0, 0. Okay? So what we know is that this length right here, that length, okay, is going to be found by the square root of, parentheses, x minus c, the quantity squared, plus y minus 0, the quantity squared. Now let's look at where that's coming from. Do you see where it's coming from?
The distance formula, the distance from B to C.
Yep, the distance from B to C. Okay? That's this minus this squared plus this minus this squared. Oh, you can't see what I'm pointing at. That's x minus c squared plus y minus 0 squared. Or I could have done c minus x squared and 0 minus y squared. It doesn't matter because I'm going to square it so all the terms do the right thing anyway. Now, what did we find up here? Look at what we have for x. So we're going to substitute that right here for x, and look at what we have for y. We're going to substitute that right there for y. Now this is going to get really crazy looking. So our a is the square root of, parentheses, x is b cosine a, okay, minus our c, quantity squared, plus y is b sine a, minus our 0, and we're getting ready to drop that, quantity squared. All of this is under the radical, okay? And so what's going to happen when we do this work? Well, this looks awful, but isn't this right here, aren't we just squaring a binomial? And haven't we told y'all that y'all needed to know that without even thinking at all? I'm going to make a little more room. So when we do that problem, and we're not even having to think about it because we really, really, really know it, we get square the first term.
B squared cosine a squared, cosine squared a.
Okay, so we're going to square the first term, okay?
Minus 2 bc cosine a.
Ooh, we've seen that somewhere. Plus c squared, yeah?
Mm-hmm. Plus b sine a quantity squared.
The 0 is going to drop out conveniently. And now let's kind of simplify some things we know here. So this gives us
b squared cosine a squared, cosine squared a, minus 2bc cosine a, plus c squared, plus b squared sine squared a.
Now, I don't know if you see it hiding in this problem here, but I'm going to actually do this. See if I can make it a little smaller because it's getting ready to get really hairy. Okay.
Well, that b squared can be factored out of the b squared cosine squared a and the b squared sine squared a, and that would be cosine squared a plus sine squared a.
Okay, hold on. Hold your horses. She's seeing the algebra. Here's what we're going to do. We are going to group together. You see the cosine squared and the sine squared? You should know what that is. So we are going to put this together. B squared cosine squared a plus b squared sine squared a, okay, minus this, we're going to go ahead and do the plus c squared and minus this 2bc cosine a. Okay? Now, what Ms. Miller was saying is she sees that b squared right there. So, we now have what?
B squared times quantity cosine squared a plus sine squared a.
What's that? What's that? What's that?
1!
That is 1, yes. Plus our c squared minus 2bc times the cosine of a. That looks horrible, but this is 1. So now look at what we have. We have a, remember we were solving for a. A is equal to the square root of b squared times 1 plus c squared minus 2bc cosine a. And so if we square both sides, we get a squared equal to b squared plus c squared minus 2bc cosine A. Okay? What we see here is that in the formula, these are the two sides, your b squared and your c squared. Your b and c are the two sides that surround your a. So when you're using this formula, everything on this side is the two sides that surround the angle. That'll help you. And that way you don't have to memorize all 6 formulas, you can memorize one. Just remember that if you are looking for a side, then it is the other two sides that go in the formula and the angle formed by those two sides. All right, it's really quite simple to use. Let's go to a problem and use it. Oh, look, we just did that. Now we're going to go to a problem.
So here's an example.
I'll write it up, or I'll write it up.
Find the lengths of side C for the given angle, the given triangle. Okay, so we want to know what C is. We know what the big C, the angle C is. That's 141 degrees. And we know that A equals 3 and B equals 2. Okay, so I'm going to write out my equation. I'm going to just write out C squared equals A squared plus B squared minus 2AC AB cosine big C. Okay, I got too excited about the C's. All right, so now I'm just going to plug stuff in. C squared equals 3 squared plus 2 squared minus 2 times 3 times 2 cosine of 141.
Let's move that over. Can we move that over?
Yeah, there we go. Okay, which equals 9 plus 4 minus 12 cosine of 141.
Degrees.
Because this is in degrees, guys, so we're going to have to make sure that our calculator is in degrees. Okay, so when you put it in your calculator.
Do this stuff first. Yeah, sorry.
So we get this equals 13 minus 12 cosine of 141 degrees.
Okay, note! When we do this, this is not 13 minus 12 times the cosine of 141.
Right.
Okay? You have to do the 12 cosine 141 first. So now we can approximate.
This is approximately 13 minus negative 9.3258. Okay, so C squared is approximately 22.3258. And that means that C, once I take the square root, is approximately 4.725.
Now, some prior knowledge that we have here is that you have two sides of a triangle, and remember that in geometry you learned that two sides that we knew, so A plus B together has to be bigger than C, and A and B is 3 plus 2, so 5 has to be bigger than C, and notice that we found C to be 4 point something, so 5 certainly is bigger than C, based on our C. Okay? You have to bring prior knowledge into the problem. All right?
Okay, so let's look at the next one. Solve the triangle. And when we mean solve the triangle, that means find all the missing information. So here we have what A, B, and C equal. We have A is 43, B is 39, and C is 51.
Ooh, we're given 3 sides.
Okay, that means we have to solve for an angle. So,
let's start with A.
Okay.
Now, if we're looking for angle A, that means that we had B squared and C squared as a part of the formula before, and now it subtracts A squared, and then this is going to be over 2 times BC. Again, you can go back to the formula page. We need to go back to it here. Notice that when I'm looking for an angle, okay, the two sides, we're looking at angle A. The two sides that are squared and added are the two sides making up angle A, and then we subtract the side opposite the angle we know, divided by 2 times those two sides that we had. So that's kind of a way to remember it. You might need to listen to that tape again, that part of the video. So here we go. So now we'll substitute in. You always want to write the problem down before you substitute because you might actually substitute incorrectly.
Okay, so we have 2 times b, which is 39, times c, which is 51. And 39 is a really big number, and 51 is a really big number squared. So you know what? Why on earth would I want to just square everything in my calculator when I could just plug it all in at one time? One step. So I'm just going to plug it all in nice and easy and get the approximate answer, which is 0.571393. Blah, blah, blah.
Yeah, and now the next part that we're getting ready to do, remember that you want to use the stored information in the calculator. So A.
So use A is approximately the cosine inverse of the stored information in your calculator. Okay? Second, or control enter gives you the answer, or no, control negative sign gives you the answer stuff. So that's useful, or you can just arrow up and copy paste it. So we get A is approximately 55 degrees. We're going to round our angles to the nearest degree. So that's why it's okay for us to have an integer.
Yeah, now let's look at one other thing we should have noticed before we started on this. Look at the order of the sides. What is the shortest side?
B is the shortest side.
Yeah, so we have 39, which is less than 43, which is less than 51. So the really important thing we should take away from that is our biggest angle then has to be opposite the biggest side, and our smallest angle is going to have to be.
C is the biggest side.
Yeah, it's the biggest side. Ha! My badness. That's side C. 39. Length of 39 is opposite side B, angle B, excuse me, and 43 is opposite angle A. Okay, so we need to be sure that we pay attention to this. So what should happen is A should be our middle angle, so we should have a bigger angle for C and a smaller angle for B. We should just pay attention to things like that. Okay.
Okay, so we're going to go ahead and solve for the cosine of B.
Now, which sides would make up angle B?
A and C.
Okay.
So we're going to have A squared plus C squared minus B squared over 2AC.
Yep. See how that works? Okay. So
we've got A squared, which is 43 squared, plus C squared, which is 51 squared, minus B squared, which is 39 squared, all over 2 times 43 times 51. That equals, once I just plug it into my calculator, the cosine of B. Oh, we're going to go all the way.
yeah, we're going to just, yeah.
All right, so.
I got lazy when I was doing these problems. So, yeah,
all right, so B is approximately.
Is the angle whose cosine is
all
of that.
Wonderful stuff. So B is approximately 48 degrees when you plug them all in.
Hey, and look at that. We expected to have an angle that was smaller than 55, and we did get one smaller than 55.
Okay.
How should we find C?
Well, there's an easy way and a hard way. You can either do the whole stinking thing again and find the cosine of C and then solve for C, or you can know that the sum of the triangle's angles equals 180, and so you would use 55 and 48, and you would get 103.
And then subtract that from
180. 103, 103,
103. And we get what, 77?
Yeah.
Is that right?
Mm-hmm.
And what did we find? C needed to be the biggest angle because it was the biggest side, and in fact it is.
Yes. Okay, so now go to chapter 110.1 and work numbers 3 and 9. And don't forget to put your calculators in degree mode. Big deal. All right, and that was it. So have a great day. Thank you for watching the lovely video. email me and Miss Dockstader, depending on which you have.
Yeah. I don't want Ms. Miller's emails.
They know. Bye.
Bye.